What is up, loud teachers and students? Welcome to Learning is Not Quiet. Multiply and divide by tens notes. Today we are going to talk about multiplying and dividing by numbers that end in zeros. While this may sound scary, I promise it's a lot easier than you think. Let's get started. As always, especially during this time where math learning is totally different, we want to be mindful about this experience. So let's take a deep breath in and out. This time when you take a deep breath in, I want you to breathe in all of your intelligence, all of your capability, all of your strengths. And as you breathe out, I want you to let go of any doubts you have in yourself. You are smart, you are strong, you are capable, and you are going to do an awesome job with this learning today. So let's begin. We're going to begin with a number talk to kind of practice our fluency or our understanding of how numbers work. So you probably have seen this problem before, 6 times 10. It should be an automatic math fact for you. 6 times 10 is 60. Now, I want you to think through all of the ways that you could solve this problem, 6 times 100. Hint, you may want to use that previous math fact to help you answer this one. You can also feel free to pause this video, especially if you're responding in a beautiful paragraph on your worksheet. Otherwise, let's talk this through. So a couple ways, especially if we're using our previous question to help answer this one, is we know that 6 times 10 is 60. So if we multiply 60 times another 10, either using the algorithm or prior knowledge, we know that that's 600. Another way we could think about this is with base 10 blocks. If I have one 100 block and then I repeat that 6 times, I'll have 600. I could do this with repeated addition. Add 100 6 times, which would be 600. There's so many other ways that you can solve this, so be creative, be smart, and give your best answer.
Yeah!
Now let's talk about some vocabulary, some words I want you to know before we dive deeper into this lesson. The first word is base. Base is the larger number in an exponent. This is the number that gets multiplied by itself. Our next vocabulary word is exponent. This is the smaller number that is shown to the upper right of the base. This is the number of times that the base is multiplied by itself. Be honest with me, do you even lift the exponent, bro? In all seriousness, this is what that number would actually look like. You see our big number is the base. Remember, this is the number that gets multiplied by itself, and the exponent is the number up high, which shows us how many times we're going to multiply that number by itself. And you see here that we have an example of what this would look like in regular form. 10 times 10 times 10. Board. Now let's see what this looks like. Our 6 is our base, our 4 is our exponent. This would equal 6 times 6 times 6. So how exactly do we multiply numbers by tens? When multiplying any number by 10, you may have noticed that you just add a 0 to that digit, like our example, 6 times 10 is 60. So the question becomes, how do I multiply any numbers by tens, or any numbers by a number that ends in 0? When multiplying any number by 10, 100, 1,000, and so on, you are just moving the digits or series of digits over to the left. Remember that we're in base 10 system, which means that we are just moving it over the number of spaces that there are zeros for.
Wow!
For example, 7 times 10 equals 70. You probably already know that from your math facts. There is one 10 or one 0 with our 7, so we can move the digit over 1 in our place value chart. If we're multiplying, we move it to the left. If we're dividing, we move it to the right. Remember, zeros are placeholders and help us move the digits over. Let's dive deep into some strategies that we can use when solving this type of problem. Specifically, a problem where we're multiplying a number times 1 with a certain number of zeros after it. Now you might be like, internet crazy lady, why are we learning more than one strategy? Math is already hard enough. You do not need to make it harder. Well, the thing is, one strategy might work well for you, but it might be a different strategy that works best for your next door neighbor. You'll never know unless you learn multiple ways of doing the problem which one works best for your brain. Second of all, the more strategies we know, the easier the problems get because we understand how the math is working a little bit better. So let's begin with strategy number 1, and that's a place value chart. Now, before we freak out about place value chart being a crazy fancy word, all a place value chart is a rectangle with a bunch of boxes inside. Basically, a table. That's all it is. You might have seen something like this before if your school uses Engage New York or Eureka Math or curriculum like that. So the first thing we're going to do is we're going to place that first number. In this example, it's 7 times 10, so we're going to place that 7 on the top. Remember, there is an unlimited number of zeros after the decimal. We're going to come back to that a little bit later in this video. You want to make sure in your place value chart that the decimals are stacked on top of each other from the first row to the second row. In this particular strategy, we're moving the digits, we're not moving the decimal. Very important. In a place value chart strategy, the decimal stays in the same spot. Then we're going to move our digits over the number of zeros that we see in our problem. So if we have 7 times 10, 10 has 1 0 in it, so we're going to move that 7 over 1 to the left. And we're moving it to the left because we're multiplying, right? So our number is generally with whole numbers getting bigger. Now let's move on over to the whiteboard. Remember, there are 3 ways to multiply or divide numbers by tens, or any number that has a bunch of zeros after it. The first way we're talking about is a place value chart. You're going to see me draw a rectangle and a line through it with a bunch of lines that way and stacking those decimals on top of each other. Remember, the decimal doesn't move. To multiply, we're going to slide our digits to the left. To divide, we're going to slide our digits to the right. Let's take a look at this in a chant. Multiply, slide to the left. Divide, slide to the right. Multiply, slide to the left. Divide, slide to the right. Now let's take a look at an example problem. We're going to multiply 62 times 100. You're going to see me plug 62 into the top row of this place value chart. Remember, each whole number has an imaginary decimal point after it. I'm multiplying by 100, so I'm looking at how many zeros are in my number 100. I'm multiplying, so I'm sliding to the left. Remember, I'm sliding my digits. You're seeing me cross off the zeros because that helps me make sure I'm moving my number over the correct number of spaces. My answer is 6,200. Now let's take a look at this if we were to do this the opposite way. So instead of multiplying, we're going to divide 62 by 100. I'm going to plug my 62 into my place value chart next to that imaginary decimal. I'm dividing, so I'm moving to the right. I move over 2 spaces again because I'm dividing by 100, so my answer is 62 hundredths. Now we're going to move on to strategy numero dos, moving the decimal. So again, remember, this is strategies for problems that are multiplying a number times a 1 with a certain number of zeros after it. So for this one, we're moving the decimal and the number itself stays in place. Again, remember, all whole numbers have a decimal and then an unlimited number of zeros after it. You can also think of this as moving the decimal over the number of zeros. For multiplying, we're going to move the decimal to the right. And that makes sense, right? In our place value chart, we shifted the digits to the left. In this move the decimal strategy, we're moving the decimal to the right. We're basically moving the number in the same direction. So 7 times 10, 10 has 1 0, so we're going to move that decimal 1 to the right. Now our answer is 70.
Ooh.
Now let's move on over to that whiteboard, but we're working on strategy number 2. Move the decimal and our number stays in place. Let's take a look at our example problem. 647 times 1,000. So remember, there's an imaginary decimal after 647. Put it in place. Now we're moving it to the right because we're multiplying 3 spaces because there's 3 zeros. Notice how I cross off those zeros to make it easier for myself. My answer is 647,000. Now let's try it the other way. 647 divided by 1,000. Again, I'm writing my number, I'm plugging in that imaginary decimal. This time, because I'm dividing, I'm moving to the left. I'm going to move over 3 spaces. I'm getting rid of my original decimal. So my answer is 647 thousandths. Now it's your turn to try both of these strategies, place value chart and move the decimal. If you want extra time, you can pause each of these questions and solve and then play when you're ready to see the answer. For an added challenge, try to solve the whole question using the strategy before the answer appears. Good luck, you've got this. Now, let's do the opposite. Instead of multiplying, we're going to divide by a 1 with a certain number of zeros behind it. An example question would be 7 divided by 10 equals what quotient? Instead of sliding the number to the left, we're going to slide the number to the right, the number of zeros. Remember, multiply, slide to the left, divide, slide to the right. In 7 divided by 10, notice I put 7. It's a whole number and it has an imaginary decimal next to it. Remember, my decimal does not move. I'm going to slide it to the right 1 space because 10 has 1 0. So my answer here is 7/10. Now it's time for strategy number 2. The same thing is true with moving the decimal. Instead of moving the decimal to the right 1 place, we're going to slide it to the left. So remember, in this strategy, our decimal does the moving, our number stays in place. So we're sliding it 1 space because 10 has 1 0. So again, my answer is 7/10. Notice how the quotient is the same no matter what strategy I'm using. Now it's time to practice. Solve each of these problems, and you can pause in between, and when you're ready, push play for the answer. Or for an added challenge, try to solve the question before the answer appears. Let's head to the whiteboard for one more side note. We can also use this with powers of 10. That's with that base and exponent if my base is a 10. So you see me drawing a place value chart and plugging my decimals in just like normal. I'm plugging my first number 6 in just like normal. Now I'm multiplying, so I'm sliding to the left. I'm going to move 3 spaces because my exponent is a 3. So really I'm multiplying 6 times 1,000. So you see me moving my 6 over 3 spaces and filling in the extra zeros. Easy, right? I can also use my decimal sliding strategy when multiplying or dividing by powers of 10. This time I'm moving my decimal to the right. I'm moving it over, you guessed it, 3 spaces. I'm filling in my zeros, and my answer is 6,000. Notice that my product is the same no matter which strategy I use. Now we can use our newfound knowledge to solve a bunch of different questions. This is strategy number 3, called front numbers first strategy. For this one, it's not just multiplying by 1 with a bunch of zeros. It can be any digit or digits with a bunch of zeros that you're multiplying. For this, we multiply the front numbers first and then add the number of zeros from both numbers you are trying to multiply. So in this example, we're multiplying 2 times 3, which we know is 6, and then there's a 0 next to the 2 and a 0 next to the 3, so there are 2 zeros in my answer. My answer here is 600. Now I think it's time for a song to remember this strategy. It is to the tune of A Whole New World from Aladdin, and don't be afraid to be a nerd and sing. Nobody's watching. Let's begin. If I must multiply two whole numbers with zeros, multiply the front digits like normal and add the O's. This is because we're just moving it over in the place value system. Because it's base 10, each zero then just moves it over one space to the left. You know the drill. Time to practice. Try to figure out what the answer is to each of these questions before the answer appears. You've got it. You guessed it, you can also do this strategy with division. You can do this by dividing the front numbers and then crossing off the zeros. In this example, I start by dividing 25 by 5. It works out evenly, so my answer is 5. I have 2 zeros in my divisor and 2 zeros in my dividend, so they cancel each other out, so my answer is 5. Let's head to the whiteboard for an example. We're going to multiply 60 by 120. I'm going to start by multiplying my two front digits, 6 times 12, which my answer is 72. Now I'm going to add the 2 zeros from my original problem. Notice how I like to cross off the zeros to make sure I'm doing it correctly. Now let's look at an example with division. We're going to divide 14,000, or 14 with 3 zeros, divided by 700, or 7 with 2 zeros. We're going to start by dividing our first front numbers. 14 divided by 7 is 2, which you should know from your math facts. Now I'm going to cross off a 0 from my divisor, and then a 0 for my dividend, a 0 for my divisor, a 0 for my dividend. There's no zeros left in my divisor, so I'm going to carry my leftover 0 to my quotient. My answer here is 20.
Oops.
Now it's for some front numbers first strategy dividing practice. Try to solve before the answer appears. We can use the same skills to answer questions like this. How many times bigger is one number than another? Step number 1, put the numbers into a place value chart, making sure the decimals are in the correct spot and stacked. Step 2, how many spaces do you have to move over the digits of the first number to get the second? Step 3, reread the question. Make sure that you're answering it. If you need to use an operation, ask yourself, which direction are you traveling? If it's multiplication, you're shifting the number to the left, and if it's division, you're shifting the number to the right. Let's see this in action. Practice. How many times bigger is 2,020? Step 1. Put the numbers in a place value chart, making sure the decimals are in the correct spot and stacked. Notice that my two front digits are the same. The second step is I'm asking myself, how many spaces do I need to move it over? You're going to see, forget from my first 2 to my second 2, I'm moving it over 1, 2 spaces. Step 3, reread the question, make sure you are answering it. If you need to use an operation, ask yourself, which direction are you traveling? In this case, we're shifting to the right. So we would be using division, but our question is asking how many times bigger is 2,100? So this is a 1 with 2 zeros because we've shifted it over 2 places. So 2,000 is 100 times bigger than 20. It is time for a multiplication activity. You will need Fruit Loops, Apple Jacks, or another large zero-shaped object. If you want to eat the manipulatives afterwards, make sure you're doing your work on a clean surface. You are going to do this by yourself, even though the first direction says in a pair. Either do this socially distanced at school or in front of your computer at home. For each of the questions on your worksheet, set up the question by rewriting the front numbers and replacing the zeros in the question with Fruit Loops or your other zero-shaped manipulative. Pennies work great, Pebbles work great. Anything that you can find works just fine as long as you can move it. Step 3. Multiply the front numbers, then, drawing an equal sign on your paper, carry over the Fruit Loop zeros to get your final answer. Check with the calculator to make sure that you got your answer correct. Let's do this first one together. We're multiplying 60 times 2,000. You'll see that I've rewritten the question and replaced my zeros with my manipulatives. I'm going to multiply 6 times 2, which is 12, and I write that product down. I carry down all 4 zeros from my factors or from my original question and bring them down to my answer. So here I have 120,000. I check with a calculator, my answer is correct, and if you're using edible manipulatives, go ahead and eat it. Complete the rest of the questions from your activity on your worksheet. Now, let's do the same thing but with division. You will need the same manipulatives, and if you're going to eat it, do it on a clean work surface. You're going to do this by yourself. For each of the questions on your activity sheet, set up the question by rewriting the front numbers and replacing the zeros in the question with Fruit Loops. Sounds familiar? Divide the front numbers if you can and cross off the zeros by eating one from the divisor and one for the dividend. If you're using non-edible manipulatives, just move them off to the side. Step 4, check with the calculator. If you're right and you have edible manipulatives, go ahead and eat it. Let's try this first example together. 20,000 divided by 500 equals what? I cross off the zeros by eating them, and my answer here is 40. We can do the same thing with these questions. How many times bigger is 70 than 7? Again, use your Fruit Loops for your zeros, and you can see how many times do I have to move that 7 over? 1 time, so my answer is 10. Thank you so much for joining me today for this lesson. Make sure you answer your exit ticket to the best of your ability, and great job. Thank you so much, awesome teachers and students, for joining me. I know you did an awesome job. Teachers, for the worksheet that goes with this lesson, please visit my store at teacherspayteachers.com. Search for Learning is Not Quiet. If you want to help support this channel and make sure that students are still getting the math education that they need during this difficult time, you can join me on Patreon. Any little bit helps. Links for both the worksheet, my store, and Patreon are in the description. Have a wonderful day.